Here we have AP Calculus BC problem. Okay, let's go to the question. A tank contains 50 liters of oil at time t equals to 4 hours. Oil is being pumped into the tank at a rate of R of t, where R of t is measured in liters per hour and t is measured in hours. Selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals to 15 hours? Okay, now let's think in general. Oil is being pumped into the tank at the rate of 15 liters per hour for 4 hours. Now, I just want to find the amount of oil in the tank after 4 hours. What do we have to do? We have to multiply the number of hours, 4, and the rate at which the oil is being pumped into the tank per hour, that is 15. 4 times 15 is 60. So after 4 hours, we'll be having 60 liters of oil in the tank. Okay, in the given scenario, to find the number of liters of oil in the tank, what we have to do is we have to multiply the number of hours and the rate at which the oil is being pumped into the tank. And we have to use right Riemann sum approximation to find the number of liters of oil in the tank. Okay, now let me write the stuff over here. Right Riemann sum approximation, okay, equals to delta T1 times R1 positive, delta T2 times R2 positive, delta T3 times R3. Okay, delta T1 gives the time duration is the first subinterval, and this is the rate at which the oil is being pumped into the tank. So this is the result for the first subinterval, and this is the result for the second subinterval, and this one is for the third subinterval, because we have to do with this one 3 subintervals. Okay, when I go over the data in the table, we have 3 subintervals. The first one is from 4 to 7, that is 4, 7. And the second one is from t equals to 7 to 12. Then we have 7, 12. And the third one is from t equals to 12 to t equals to 15. That is 12, 15. Okay, the time duration in the first subinterval is 3 hours. That is 7, -4. And time duration for the second subinterval, we have to subtract the minimum value 7 from the maximum value 12. 12 -7 is 5. That is 5 hours. And time duration for the third subinterval is 3. That is 3 hours. Okay, here for the first subinterval, the value of delta T1 is 3. And so now we have to consider the rate at which the oil is being pumped into the tank. And since we do right Riemann sum, we have to take the rate, the right end point. Okay, here in the first subinterval, the right end point is 7. So we have to get the rate at time t is equal to 7 hours. So that is 6.2. Let me plug in 6.2 for R1. Okay. We have to do the same thing for other 2 subintervals. Delta T2 is the time duration in the second subinterval, that is 5 hours. Let me plug in 5 for delta T2. And R2 is the rate at which the oil is being pumped. So the same thing, right Riemann sum. So I have to consider the right end point, the second subinterval, that is 12. When t equals to 12, the rate is 5.9. Let's plug in now 5.9 for R2. Delta T3, that is the time duration of the third subinterval is 3. And when t equals to 15, the rate is 5.6. Let me plug in now 5.6. Okay, here 3 times 6.2 is 18.6. And 5 times 5.9 is 29.5. Positive. 3 times 5.6 is 16.8. Okay, here when I add all these values, I'm getting 64.9. Okay, now I got the amount of oil pumped into the tank from t is equal to 4 hours to t equals to 15 hours. That is 64.9 liters. But initially we have 50 liters of oil at the time t equals to 4 hours. Now to find the total number of liters of oil at time t equals to 15 hours, we have to add the initial amount of oil, that is 50 liters, to the oil 64.9 liters are pumped into the tank from t is equal to 4 to 15 hours. So then we have 50 positive 64.9, that is equal to 114.9 liters. And we find this value in answer choice C. The correct answer choice for this question is C.